Alright, continuing section 6.1, we're now look at factoring by grouping. And key indication when you're going to use this method is when you have four terms. Okay, so you see here we have four different terms. Pretty good indication this is the method you're going to need to use. Now, with any type of factoring problem, any problem that asks you to factor, the first thing you always want to check is for a GCF, what we were doing on the last video. So, looking at this expression, we want to try to first find a GCF. 6ax plus 12bx plus a plus 2b. So first of all, could we pull out a coefficient GCF? A GCF is in terms of the coefficients. Well, we have 6, 12, no coefficient, and 2. 2 goes into 2, 6, and 12, but because that single a doesn't have a coefficient, we wouldn't be able to divide a 2 out of it. Next, we could look at the variables, but there is no variable that's common to all four of the terms. Some have an a, some have b's, some have x's, but there is no variable that's common to all four. So we wouldn't be able to pull out a GCF and divide that out. So this is definitely then an example when you should know, okay, I have to use this grouping method. So the first step is to set your four terms into two groups. So two groups of 2. So we can take our 6ax plus 12bx, group those together, and then you always want addition in between the two sets. And then we have an a plus 2b as our other grouping. So now we have to find a GCF out of each of the two groups, and we do that individually. So there is no GCF of all four terms, but we can find a GCF for the two different groupings, so two separate GCFs. So looking at our first grouping, 6ax and plus 12bx, looking at those two terms, we want to determine what our GCF would be here. So what number will go into 6 and into 12? That would be 6. And then do we have a variable piece that'd be common? Well, both terms have an x in them, so we can divide out, we can bring out an x as well as part of our GCF. Next part, a plus 2b, what is going to be common in those two terms? Well, we can't pull out a coefficient for our GCF because this technically has a 1, and so there is no number, and then we have two different variables, a and b. There's no variable that's common to these two. So here what we actually end up saying is that our GCF, if there is no GCF, technically 1 is always going to, at least 1 will be something's GCF, because 1 can go into anything. So there we found our GCF, 6x, and our other grouping had a GCF of 1. Finishing up this part of the problem, we then have to factor this out of each grouping. So in the first grouping up here, if we pulled a 6x out, we can divide 6x out of each term. Or we can look at it as 6x times what, and what will get us back to 6ax and 12bx. So 6x times an a will get us back to 6ax, and then 6x times a positive 2 will get us 12, but we need 12bx. We already have the x, so we need 2b. Plus, okay, if our GCF is 1, we want to put the 1 out front, and then, well, dividing a 1 out is going to leave us with the exact same expression inside the parentheses, a plus 2b. And what we have here, if we know, this is where you know you've done the problem correctly, because you have a plus 2b, a plus 2b, we have this common binomial piece, the same two terms inside both parentheses. This is when you know you've done the problem correctly up until this point. Okay. So now, in order to finish the problem, we have to write it in a completely factored form, which is going to be some sort of a parentheses factor times another parentheses factor. So what we do is we put the common binomial and the GCFs in separate parentheses. Okay. So what I mean by that is we take our two GCFs that we had written out front, the 6x and the 1, and because it's a positive one, we want to write a factor as 6x plus 1. And then in the other grouping, we have a plus 2b, another a plus 2b. We put that common binomial in its own separate parenthesis. So even though it showed up twice in the step above, in your final answer, you're only going to see it written once. And we can talk about why is this expression in purple equal to this expression here I just wrote in green. Why did the a plus b only show up once? And you can think about what would happen if you were to FOIL this answer out. Okay, what we have right here, what if we were to FOIL and double distribute, or use the box method? Okay, so we can use FOIL or box method to check. Well, in doing that, we would take this 6x and we would be distributing it to the a plus 2b. 6x times a, 6x times 2b. Well, that would be the same thing we would be doing up here if we distributed the 6x to the a plus 2b. The next step in FOIL, or box method, would be taking this 1 and distribute it to both terms over here. 1 times the a, 1 times the 2b. Well, that's the same thing we'd have up here if we took this a and distribute it to that parenthesis. So you see, if we were to do FOIL or the box method here, it'd be the same 4 multiplications that if we distributed here and distributed here. So that's why these two expressions are equivalent to each other. Okay? So that is actually our answer, what I have written there, the double parenthesis. But you can always use FOIL or the box method to check. Okay? So let's try another example. Looking at our second example here, we have xy minus 2y minus 4x plus 8. Okay. So first step, we want to group this into 2 sets. So this equals xy minus 2y. Here's where you have to be careful. You want addition in between each. In other words, this minus 4x, the sign, the subtraction needs to stick and stay with that 4x. So if we have addition in between the parentheses, it is a minus 4x and still a positive 8. Up here we had a negative 4x and a positive 8. Down here we need to still have a negative 4x and a positive 8. Okay. So then we had step 2, factoring out the GCF of each. What factor is common to this first parenthesis? Well, can't pull a number out, can't pull an x out because this term doesn't have an x, but they both have a y. So we can factor out a y, or we could say in this step our GCF is y. Over here, what can we factor out? Well, this 8 doesn't have an x on it, but 4 and 8 are both divisible by 4. 4 will go into 4, 4 will go into 8. So we're going to say that our GCF equals 4. Okay. Remember, as I had said here, we do want to keep addition. In between our parentheses. Okay. So now that we know our GCFs, we need to write them out front. Actually divide out our GCFs, factor them out. So y times a and x will give us xy there. And then y times a minus 2 will give us a negative 2y. Okay, to match that top parenthesis. If we factor out a 4 here, we have plus 4. And we need to see what do we need to multiply by in order to get back to the second grouping. So 4 times a negative x would give us negative 4x. And then 4 times a 2 would give us the positive 8 there. Okay. So looking at what we have right now, looks like we have a bit of an issue because at this point we should have this common binomial if we did it correctly. We don't have a common binomial. We don't have the exact same thing in our parentheses. We almost do. Okay, we have x minus 2, and here we have a negative x plus 2. They're just off by their signs. Here the x is positive, here it's negative. Here the 2 is negative, here it's positive. So what this tells us, if this ever happens, well then for our GCF, we want to pull out the opposite sign. Make it a negative 4 instead. Okay. If we make it a negative 4 instead, this will get us our common binomial. Okay. All right. So let's redo this. This equals y x minus 2. If we make it a negative 4 here, all that's going to do is change the signs. So it's going to be a positive x and a negative 2 inside here. Now we have the common binomial we're looking for. X minus 2 and x minus 2. So there we go. That's what we wanted. Now we can write our final answer. So down here in step 3, our final answer is putting our GCFs together, the y and the minus 4. And then the x minus 2, our common binomial, we write that together. Okay. And that right there is our final answer. And once again, if we want to check that answer, we can use the FOIL method or the box method. Y times x gives you xy. Y times negative 2 gives you minus 2y. Negative 4 times x gives you minus 4x. Negative 4 times negative 2 gives you a positive 8. So foiling indeed gives us back to the correct answer.